right, in 5, 4, 3. Welcome to another pre-calculus class. Right, and today we have 10-2, otherwise known as section 10-5, brought to you by, 10-6, oh nuts, 10-6, all right. Comedians over here. Brought to you by the Bumblebee. Well, that would be too close. Very comfortable. Okay, so in the buzzword and a little cloud right there, we will write down number 5. Yes, Emily?
Just put 5.
Oh, I was.
Stephanie?
Oh, did you just write the answer?
Yes, Miss Rawson. Yes, okay. Yeah, 5. Anybody pick 5?
I wanted to say
Yes.
it.
Well, did you have 5?
Yes, I did.
Congratulations. All right, and you are correct. Now, do you know why it's 5? Or did you just hear somebody else say it? Okay, why is it 5? All right, tell me. Let's go back to
Okay, it's 5 because I took 5 from and I plugged it into F, and then 3 times 5 is 15 plus 2 is 17.
All right, 17.
17, and I plugged it into G, and I put 17 minus 2 is 15, and 3 is 5.
Perfect, absolutely perfect. All right, so we get this random number 17. It's like, what does this have to do with anything? And then all of a sudden it changes back into 5. A little bit of magic there. Wonder why that happened. Okay. Could those be inverses of each other? Right? Okay, so here's how I created it. What I did was, okay, you've got y equals 3x plus 2 essentially, right?
An x for y.
And yes, to do an inverse, you switch the x's and the y's, right? Okay, it's f by g of x, so it's like y, right?
And then you solve
If you switch and resolve for y, look what happens. Take away 2 and divide by 3. Oh my goodness gracious. Those are inverses, aren't they?
Like, makes sense now.
Okay, and so that's why the 17 magically changed back to a 5, all right? So the moral of the story is, if you take a number and you do something to it, and then you do the opposite to it, it will go right back to where you started, right? Make sense? Okay, and that is very important today for some of the higher level things we'll be doing. This is pretty intense here. This is these are some abstract problems, all right? Some abstract thinking. This is kind of like when you get into college and eventually you lose all numbers in math. It's just a bunch of symbols and letters. Okay? But that's like a long time now. Okay? We'll have a little taste of that today. So, here's what we want to do. Let's start off with rule number 1 and rule number 2. All right? There are 2 rules. Okay? Rule number 1. If f and g are inverses, then I wonder what f of g of x is. X. It would have to be x. Right? Because the f and g kind of offset each other or cancel each other out, don't they? All right? Very true. Do you remember, by the way, what type of function this was back in algebra 2? Take a function and stuff it inside another function. There's a word for that, actually, for this function.
What's the first letter?
C.
Complex.
Complex? Well, no. But it doesn't begin with the CO. Matter of fact, it begins with COMP.
Computer.
A computer function. You're not even trying. Why don't I just give it away?
Composition.
Composite. Come on. All right. Somebody would get it. All right. Remember the composite functions back a while back? Algebra 2, Algebra 1? Okay. Or maybe they never even called them composite functions. I don't know. Composite.
Now it's hard for you to say.
Yeah, I know. Now you get
Composition.
He's got me all bamboozled. All right. Anyway, so I don't know if they were actually called composite, if they gave you the name in Algebra 2 or Algebra 1 or whatever, but that's what they are. Anyway, so you take something, you stick it in something else. It's kind of like a composition here. So there you go. Now, in rule number 2 is the derivative of rule number 1. So they're related. Okay? If they're related, it should be easy to remember. You don't even have to memorize rule number 2. Just take the derivative of rule number 1, it will happen automatically. So, what is the derivative of a composite function? Well, that's a good question. This is our first derivative of a composite function ever, right here. If you had to take the derivative of f of g of x, what would you do first? We're going to, and actually you'd think you might be able to do Hody High, but you actually can't because it's actually not f times g. It's actually f of g, so it's a little different. Yeah. So it's like you could almost do Hody High, it doesn't work. So if it doesn't work, to go to derivative rule or derivative world, What would happen to f? Prime, sure. But what always happens with the inside when we take the derivative? Stays the same. So let's start with that. Okay, well, I guess that's it.
Times G prime of it.
Oh, what about the
Chain rule.
chain rule, right? The most important rule in math. The derivative of the inside is
G prime of that.
g prime of x. That is a composite derivative right there, okay? That'll be important for the future. All right, I think.
Is that the power rule that you just said?
I guess it's just kind of, this is a chain rule, power rule, yeah. Just-
You
just
don't,
a-
you don't subtract the exponent at the top.
Right, because there's no exponent at all.
Okay.
I guess it's just a chain, basically. Okay? So that's a derivative right there. So if you actually stuff g into f and work this all out, or if you just use this formula, you get the same thing. Okay? So it's a nice little formula there. Now, what is the derivative of x?
1.
That would be 1. So this is always a true statement as well. Now wait, these two things are only true statements though if f and g are inverses. Okay? Always true. So we're going to use this to help us today with some functions, especially some unknown functions. All right? Okay, so let's go to example A. And example A is going to feature cosine of x plus e to the x. Now that's a crazy curve. That's some wild stuff right there. Okay? So g of x equals cosine of x plus e to the x. And h of x equals g inverse. So these are inverses. All right. Now, let's see what we will do. So I scrambled my black marker again. You kids?
I don't know who it was.
All right.
You've had tutoring since then, haven't you?
That's true. Okay. Now, okay. A key to this problem is we need to find h of x, which is the inverse of g, right? Okay? Don't write this down, because it's worthless. But wouldn't the inverse of this function right here be x equals cosine of y plus e to the y? To get an inverse, don't you just switch the x's y backwards? Okay, all right, so we'll switch a root. Now, there's your inverse, now get y by itself, right? Okay, so let's solve for y. There's only one way to break the cosine off of the y. Inverse cosine. Now it's stuck on that one. I didn't know.
Can't you subtract it?
There's only one way to get an e off of a y. Natural log. Well, now it's stuck on the cosine. You can't do it. No matter how you go about this, you can't get a single y by itself equals everything else. Okay? Not even our greatest 10 mathematicians, located strategically right below the camera, not even those guys right there could come back to life and solve this, because it is mathematically impossible to represent the inverse y equals. Okay? All right. So if it's impossible, then that's a dead end. Yet, you will still be able to answer questions about the unknown h of x that is impossible to find. Ready for this? Time for a little math magic, everybody. Abracadabra. All right.
Oh, your marker changed color.
Oh, look at that. Okay, just shook it up a little bit there. Okay, Christmas kids. What is, okay, agreed. What is the equation h of x? I do believe we just determined that it is unknown. You can't find the inverse of that function. Okay? I mean, we put it over here in a, what form is this, by the way? Not solve for y?
In terms of y.
It is,
In terms of x.
okay,
In terms of y.
it's in terms of y, which means solve for x, but it's also implicit. Yeah, it's implicit.
Yeah.
Pretty good. You know what? I'll give you a plus 10. That was
Yeah.
very nice.
Okay, Katie.
Plus 10. Steve, Kathy.
Yeah.
Okay, so it is, so several things we learned there. Okay, in terms of y, remember that, it's in terms of y, and it's implicit, but we wanted explicit. Explicit means solve for y, right? And you can't do it. So explicit is impossible. All right, so unknown, we don't know. Okay, so if that's mathematically impossible to find, I guess we can't answer anything else, but you'd be wrong. Now, believe it or not though, you can actually do a graph of it, even though you don't know the equation of it. You can actually do a graph. Do you remember, let's say we had a list of coordinates for this equation, because this equation we can graph. What if you had a list of coordinates for cosine of x plus e to the x? Do you remember what happens in inverse world to all the coordinates? They all switch backwards and create the inverse graph. Or you could reflect the inverse around the line, over the line, what?
Y equals X.
Over the line y equals x, you could draw the inverse. So you could sketch this unknown function. You just can't really name it. That's the problem. Okay? So if you can't name it, you can't do a lot of stuff with it. Well, let's try this. G of h of x. All right, let's try that first. It says, what is equivalent to g of h of x? Are these inverses in this problem? Bless you. Are these inverses? Oh, it's fun. Are these inverses? Sure they are. Oh, it's over here. All right.
Bless you. How
Yes,
do you even
these
get
are
bless you from that?
in.
Unless there was like a mallard over it or something.
That-
Where's the, yeah, it does sound like it's
We're gonna cut this in take two.
They honk.
Cut. Anyways, all right. So yes, these are inverses. All right. If the functions are inverses, what happens when you stuff h into the other one, g? You get x
X, what?
by rule number what?
One.
One. Rule number one. If you take something and stuff it into the inverse, you get x.
So it equals X.
Okay, so it equals x. Okay. Pick your favorite number, pick your lucky number, add 10 billion to it, now subtract 10 billion from it. Right back to your lucky number again. All right? Opposites. Okay, that's all it's doing. Do something to it, do the opposite to it. Same place. Okay? Now, how about this? H of g of x. Doesn't matter if it's the other order. Okay? Nope.
Minus 10 billion.
Okay, now let's do that first, and let's add to it. Same thing. Rule number one. Okay? Same exact thing. All right, so know that. Now, number four. Write an expression for g of h of x in terms of h of x. Now, that's an interesting one. Okay? All right? Yeah, that's a blessing.
Thank you.
Okay, now, g of h of x. Okay, let's try this. Do you know what it means to physically find g of anything? You know what you do with this right here? Take that and stuff it in
The turkey.
to, not stuff it, it's not Thanksgiving. Take h of x and stuff it into g. Isn't that what that means?